What's going on, everyone? In today's video, we're going to be looking at quadratic equations with a slightly different representation and how that can both help us and how we can put that into the calculator. Let's take a look. All right, so here I'm asked to plot the graph for y equals f of x, for which f of x is going to be equal to 4x minus 5 times x plus 3. All right, you may only use your GDC to check your answer. Yeah, okay, that happens a lot, which means we need to show this by hand. So what are the x-intercepts? So when we have an expanded quadratic here, meaning it's not ax squared plus bx plus c, it's going to be expanded out, so this is factored. Well, what are the x-intercepts? Remember, whenever we have an x-intercept, that automatically means that our y-coordinate is 0, our output is 0. So if we put 0 is equal to 4x minus 5x plus 3. Okay, so when would this equation be 0? So remember, if this 4 is multiplying to this term here, x minus 5, which is multiplying to this term, x plus 3, well, if this is 0, this whole thing becomes equal to 0. Or if this is 0, this whole thing becomes equal to 0. So when does x minus 5 equal 0? Well, that's when x is equal to 5. And when does x plus 3 equal to 0? It's when x is equal to negative 3. So there are my two x-intercepts. It's going to be at 5, 0, as well as negative 3, 0. And now let's find the equation of the axis of symmetry. So again, all we need to do is average out the x value of our x-intercepts. So I have 5 plus negative 3 over 2. That'll give me x is equal to 2 over 2, so x would be equal to 1. That is going to be the y-coordinate. That is going to be the x-coordinate of my vertex. It is the axis of symmetry. So if I go back to D, what are the coordinates of my vertex? Well, I know that my axis of symmetry is also my x-coordinate of the vertex. So if I do f of 1, plug that in for x, I'll be getting 5, 1 minus 5, 1 plus 3. That is going to give me f of 1 is equal to 4, negative 4 times 4. Wow, a lot of 4s. So f of 1 is going to be equal to negative 16 times 4. Negative 16 times 4, that's going to give me negative 64. My vertex is 1, negative 64. Now let's use a graphing calculator to check this. And so one important thing to note is that a lot of times graphing calculators do not like this representation. It'll give you an error. So what you need to do is just turn that into your ax squared plus bx plus c form. And well, how do you do that? Well, if you have f of x is equal to 4x minus 5x plus 3, all you need to do is just distribute this all out until you get your ax squared plus bx plus c. So f of x would be equal to 4x minus 20, and then that would be multiplied by x plus 3. So you can see this it doesn't exactly get complicated, but you will need to FOIL this out. So you'll have 4x squared plus 12x minus 20x minus 60. That is going to give you f of x is equal to 4x squared minus 8x minus 60. So that is what we're going to put into our graphing calculator, as I already have done here. 4x squared minus 8x minus 60. So now let's double check. Let us check for our zeros. Let me analyze this graph for the 0. Let me analyze this graph for the other 0. So negative 3 and 5, is that what I got? Negative 3 and 5, yes it is. All right, and then let's find my vertex. Let me go ahead and analyze the graph for the minimum point, which is there and there. 1, negative 64. That works for me. That is exactly what I got for the vertex. That is going to be the x-coordinate for the vertex. It's going to be my axis of symmetry. Excellent. So I just double checked on my calculator to make sure that my math was okay. And it is. So again, if you are given this form, very easy to find your x-intercepts, and all you need to do is just distribute out those terms in order to find your ax squared plus bx plus c form. Hope that shed a little bit of light into how to solve these kind of problems, and I'll see you all in the next video. Take care.